Hey guys, so in this video we're going to talk about linear inequalities in two variables, which are things that look like this. So let's just jump right into it. So what is a linear inequality in two variables? Well, it's an inequality of the form ax plus by is less than c, where the a, b, and c, those are just numbers, and the a and the b cannot both be 0 at the same time. Now, in this definition, I have this less than sign, but I'll tell you that this also works for any of the inequality signs, but it is inequality. Now, I think it's easiest to just jump right into showing you an example. So let's talk about how to graph y is less than or equal to 2x plus 1. So the thing is that you can actually just think of how you might graph something like, let's say consider the graph of y equals 2x plus 1. So you can think about that at first. So this is just in slope-intercept form, right? And so this would have the y-intercept of 1, so I can really start there. So I'm just going to mark that point. There's 1. And then I can count out this slope of 2, which means up 2 and over 1. So I'm going to count up 2 over 1. I'll count up 2 and I'll go over 1. Okay, so as far as like getting the party started, if you will, you kind of do the same things that you would do with a normal line. But then there's a little bit of a plot twist now with how do you take into account this less than or equal to, how do you take that into account? So the first thing that's a little bit different is how you actually represent the line. So in the case of less than or equal to or greater than or equal to, you'll just use a solid line, but if you have less than or greater than, then you use a dotted line. So in our case, we have a solid line, right, because this is less than or equal to. So far this feels just like graphing a normal line. So let's go ahead and connect these points as shown. Okay, so that's one part of this, but now let's actually think about what makes sense here. So remember that the whole thing about an inequality is that there's like a whole bunch of different answers that can work, right? So what you're going to want to do to figure this out, to kind of illustrate this deeper for you, I guess, is looking at this line, let's think about a few points that are on each side of this line. So I'm going to use this orange color. So this is going to be for some test points. So let's see. I'm going to choose a point over here. So let's see. This is the point -1, -2, -3, -4. So this is -4, 0. And then I want to choose a point on this line. So let's see. Why don't we do this one right here? So this is the point 2, 0. Okay. So I want to do a little bit of experimentation with this. So let me clear a little space, and now I want to plug in the test points. So we're going to plug in the test points. So starting with -4, 0. So I'm going to plug this right into the inequality, and I want to see if this gives me something true. So this is going to be 0 is less than or equal to 2 times -4 plus 1. So this is going to be 0 is less than or equal to -8 plus 1. So this says that 0 is less than or equal to -7. So is that true or false? That is false, right? So this side is the false side, okay? Now, let me just finish out this example. You might have a few questions on this, but let me just kind of round this idea out, and then we'll kind of sum it up a little. So I want to take a look at this other test point. So this 2, 0. So now let's plug this in again. So I've got 0 is less than or equal to 2 times 2 plus 1. So I've just plugged that point in. So I get 0 is less than or equal to 4 plus 1. So this is 0 is less than or equal to 5. And this is true, right? So this side is true. So what does this actually mean? I have this side I've written as false and this side I've written as true. Well, what this is getting at is that there are actually a whole bunch of points that can make this statement true. And so basically you choose a test point on each side of the line, and if you find that one point is true on that side, then any other points that are on this side of the line are going to make this inequality true. And any other points on this side of the line will make the inequality false. So let me just test this out maybe just a little bit farther. So I'm going to use this blue color, and let's just choose a couple more points here. And I'm just choosing these at random. It like totally doesn't matter what you choose. I like to choose something that has 0 in it, But just to kind of round this idea out, so let's see, let me use this point. So let's see, this is 0, 5, and then let me choose a point down here. So this is, let's choose this one, 0, -1. So let's see, does this like whole thing I've just discovered, does it still hold? So I'll get rid of all of this stuff here. And so let's see, so this point here, since it's on this side of the line, this should be false when I plug it into the inequality. So let's see if that happens. So this is now going to be 5 is less than or equal to 2 times 0 plus 1. So this says that 5 is less than or equal to 1. So that's still false. So what this is telling me then is that any point I choose on this side will make the inequality not work. So this side, none of these points will work in this inequality. So now let's test out 0, -1. So 0, -1. So this is going to be -1 is less than or equal to 2 times 0 plus 1. So this says that -1 is less than or equal to 1. So that's true. Okay, so now we can really see, right, like any point on this side that I plug into this inequality is going to make this inequality true. So now what I want to do is I want to represent what I've kind of just discovered in my answer. So what I'm going to do is I want to just represent all points on this side can go into this inequality. So to represent that, I am going to shade this entire side. And then my interpretation is just what we just kind of figured out. All of the points on this side of the line will make this inequality true. Okay, so that's the idea. All right, so let's take a look at a couple more of these. So I'll walk you through another one. So this is going to be a little more typical of what you see in these types of problems. So this is 3x plus 2y is greater than -6. Okay, so notice first of all, this is not in slope-intercept form. So this is in standard form. So I probably want to manipulate this a little bit. So first things first, let's take 3x plus 2y equals -6. So let's start by thinking about just this line right here and how to graph this. And so to graph this, what I would want to do is I'd want to solve for y so that I can easily see the slope-intercept form. So I'll start by subtracting off the 3x. So I've got 2y equals -3x minus 6. And then I'll divide each part by 2 to get y equals -3/2 x minus 3. Okay, so here's the line that I kind of want to sketch out. And this is in slope-intercept form. So let's see, I'm going to go ahead and start with the y-intercept of -3. So I'll go ahead and mark that, 1, 2, 3. And then I've got this slope of -3 over 2. So down 3, down 1, 2, 3, and over 1, 2. Okay, so I've got my 2 points here. I've kind of run out of room. Now before I draw this line, I have to refer back to the inequality sign right here. So just a reminder again, less than or equal to or greater than or equal to, that's a solid line. Less than or greater than is a dotted line. So in this case, I want to connect these points with a dotted line. And that's how I indicate that this equation had a greater than or a less than sign. Okay, so I'm going to just draw it out like this. So you can see there's my little dashes or dots or whatever you want to call them. Okay, so there's my line. So now we have to figure out what side of the line will have points that make this inequality true, because that's always the case. So once again, you can choose really any points that you want, totally at random. I'll just make this a little more guided. So for now, why don't we use 0, 0? I like using 0, 0 because it's just an easy point to select. And then let's see, I always like to choose something that's on an axis, on one of the axes, but why don't we'll choose this one right here. And by the way, I would highly recommend that you choose something that feels like it's solidly on that side of the line. Sometimes when you draw these lines, you can be a little bit off in your scale. So if you choose something that's super close to the line, your scale, like your drawing, could be a little bit off. So try to choose something that looks like it's solidly on one side of the line. Okay, so I'm going to use the point 0, 0, and then I'm going to compare the point, let's see, what is this? This is 2, 3, 4, 5. This is -5, -1. So you don't have to have a 0 in it, but I prefer that. So let's start with 0, 0, and let's plug that into our inequality. So I'm just going to plug that back into the original inequality. So this is going to be 3 times 0 plus 2 times 0, and I want to know, is that greater than negative 6? So this says that 0 is greater than negative 6, so that is definitely true. So it looks like this side is true. Now, I want to still plug in the other point, because every once in a while you can make a mathematical error, and you shouldn't have that both sides are true. So one side should always be true and one side should always be false, so it's always a good check to make sure that your other point is actually false. So I'm going to take 3 times negative 5 plus 2 times negative 1 is greater than negative 6. So let's see, this is negative 15 minus 2, this is greater than negative 6. So this is negative 17 is greater than negative 6. And that is false. So all the points on this side will not make the inequality true, but all of the points on this side will make the inequality true. So now I want to just color this side. And if you chose other points, like I said, that would be fine. And you could always choose like multiple points if you want to be super thorough, like we did in that first example. Okay, so there's your graph. Okay, so now for B here, there is a slight plot twist that I want to warn you about. So I want you to remember what happens when you divide by things that are negative. So to begin, I want to get this equation to be in that slope-intercept form. And so what I'm going to do is I'm actually going to just rearrange this particular equation. So I'm not going to have an equal sign here or anything. I'm actually just going to think about solving this equation for y for a moment. So to do that, so I'm going to go ahead and subtract off the 5x. So I get negative 2y is less than or equal to negative 5x plus 10. And now here's the part that I was kind of talking about. So notice that I'm dividing everything by negative 2. And so remember, the thing with inequalities is when you divide by a negative, what ends up happening is you have to flip the direction of the inequality like this. And so that will matter. So what I want to do is I just want to note on the side here. So this will be y is greater than or equal to 5 over 2x minus 5. So now I have this in a format that I can actually graph. So let me clear off this work. And now let's go ahead and graph. So let's see. I've got a y-intercept of negative 5. So 1, 2, 3, 4, 5. And I have a slope of 5 over 2. So I'll go up 1, 2, 3, 4, 5 over 2. And this is a or equal to sign. So that means I get a solid line. So there's the line that I want to work with. So now I can go ahead and just start grabbing points. So in this case, let's see, I'll take this point here. So we'll start with 0, 0. Now I can plug this really into either one of these equations. I'm just going to plug it in here because I think it will be easier to calculate with. But if I wanted to plug it into the other one, that would have been fine too. So if I do this, I get 0 is less than or equal to 10, and so that is true. Okay, now I want to make sure that the point on the other side gives me something false. So let's go ahead and test this for 1, 2, 3, 4. This is 4, 0. So again, you just choose any point at random on each side of the line. So it doesn't matter what you choose. They just have to be on opposite sides. So if I test this, I get 5 times 4 minus 2 times 0 is less than or equal to 10. 10. And this gives me 20 is less than or equal to 10, which is definitely false. So this point here tells me this side I will not shade, but this side here I will shade. And so there you have it, right like that. So I've got one more problem here in this video, and I would recommend that you just try this whole problem on your own. So pause and then hit play when you're ready. Okay, so first things first, so I'm going to think of this as negative 3x plus 4y equals negative 12. So I'll start by adding the 3x to each side. So I get 4y equals 3x minus 12. And I will divide all sides by 4 to get y equals 3 over 4x minus 3. Okay, so first let me sketch some points. So let's see, I come down 1, 2, 3. I'm going to go up 1, 2, 3 over 1, 2, 3, 4. And then I'm going to use a dotted line because it is a less than. So there's my initial line. Okay, so let me clear off this work. And now let's select some points here. So I'll take 0, 0. Then I'll take this point down here. So this is 0, 0. And then this is 0. Let's see, what is this? 1, 2, 3, 4, 5, 6. So this is 0, negative 6. So let's compare these now. So starting with 0, 0. So this is negative 3 times 0 plus 4 times 0. So is this less than negative 12? This will give me 0 is less than negative 12. So this is false. Okay, so hopefully then my other point works out. So I get 0, negative 6. So let's plug that in. So this is negative 3 times 0 plus 4 times negative 6. So is that less than negative 12? And this gives me negative 24 is less than negative 12, so that is true. So, regardless of what point you chose, this is the side that you would want to shade. Now, if you didn't get that, if you got the opposite conclusion, redo your math one more time, double check like the math that you did or choose a different point. That sometimes can be something that can trip people up. And so otherwise, that concludes this video, guys. So thanks for watching. I'll catch you next time.